Hello everyone, welcome back to our channel. Let's see the next reaction, that is Barton reaction. The first component is what? Statement. If you see the statement, this is the what? Introduction of oxime group at delta position to the alcohol. It means that what? The reactant is going to be the alcohol. At the delta position, we are going to introduce the particular moiety that is commonly called as oxime moiety. We can reframe the statement in another way also. If you see the second statement, photolytic decomposition of alkyl nitrites into nitroso alcohols, commonly called as Barton reaction. If you see this particular situation, here the people are saying alkyl nitrites. Nitrites are going to be converted into what? Nitroso alcohols. We all know that NaNO2, sodium nitrite. If sodium is replaced with some organic group, that is commonly called as what? Alkyl nitrite. So these kind of alkyl nitrites are going to be converted into the corresponding nitroso alcohols. Let's see the general equation, thereby we can easily understand the statement. If you see the general equation, the reactants are what? Alcohols. See this reactant, it is having OH group or not? If you see this particular reactant, what happens? Alpha position, beta position, gamma position and delta position. At delta position, we are observing hydrogen or not. So the delta position must be having the hydrogen atom, then only these kind of compounds are converted into the corresponding oximes or nitroso alcohols. So initially what happens? These molecules are treated with nitrosyl chloride, NOCl, in presence of a base commonly called as pyridine, followed by light. See the statement, photolytic decomposition. It means that what? The reaction is going to be takes place in presence of photolytic conditions, not the thermal conditions. So it is producing what? At a delta position, hydrogen is replaced with NO group. That's why this is commonly called as nitroso alcohol. The nitroso alcohol involving in the isomerism. This process is what? Isomerism. Here the proton is involving in the isomerism. Because of the isomerism, we are coming up with oximes. Let's see the mechanism. In the mechanism, what happens? The alcohol is initially treated with nitrosyl chloride. Here see, H and Cl removed in the form of HCl. Why? Because we are using the base or not. The base removes the proton from this one. You are going to get O minus. The O minus is going to attack on the nitrogen. Thereby, Cl is removed in the form of Cl minus. Simplicity, we are saying the removal of HCl produces your alkyl nitrite. See the formula, RONO. If you see this particular carbon chain, it is the R group, ONO. Right? This reaction is the example of what? Photolytic decomposition. We are using the light radiation, right? Always remember one thing, if you use the light radiation, the mechanism is going to be the free radical mechanism, not the ionic mechanism. It means that what? The homolytic cleavage of a particular bond takes place. See this? Here the homolytic cleavage of oxygen-nitrogen bond takes place. Thereby we are getting O radical and NO radical. See this? O radical and we removed NO radical. Now what happens? At the delta position, we are having hydrogen or not? That hydrogen is transferring from the delta position to this oxygen radical. Oxygen is having radical, means it wants again radical or not? It means that what? The hydrogen is going to be removed in the form of H radical. But we need to observe one thing here. The removal of a H radical from the delta position is not the feasible one. Because of that reason, what the people are saying, before the elimination of H radical, it is going to form a 6-membered transition state. The 6-member transition state subjected to decomposition, thereby this hydrogen is removed in the form of hydrogen radical and attaches to that O radical. In the previous step, what happens? We have removed the NO radical or not? The NO radical is going to attach at the delta position. That's why we are coming up with what? NO. This one is involving in the keto-enol cathomerism, type 1. That's why what happens? The nitroso alcohol is converted into the corresponding oxime. So this is very simple mechanism or not? Let's see the applications. This one is very useful in steroid moieties. Barton reaction is always going to be observed in the conversions of steroid moieties. Let's see the first application. Here we have OH group. With respect to this OH group, this is alpha position, beta position, gamma position, and this one is what? This methyl group is delta position. At the delta position, what happens? One proton is removed and simply we are placing what? NO group. The NO is subjected to isomerism, then coming up with what? Oxime. See the product? Alpha, beta, gamma and delta. One of the proton is replaced with the NO, that is involving in the isomerism, so thereby double bond NOH. Here we need to remember one important thing. See this one. If you see this particular bond, this is above the plane or not? At the delta position, the hydrogen must be in the upper position or the above the plane. Then only this reaction takes place. Suppose if OH is in the above the plane, the hydrogen in the below the plane, the reaction will not take place. It means that what? We are observing the stereochemistry or not. In this particular moiety, along with this particular delta hydrogen, here we are getting one more delta 1 also. Here also we are having delta hydrogen. But the thing is that here this delta hydrogen is going to influence this pi bond. Thereby what happens? If you see the mechanism, in the mechanism we are observing the O radical or not? In order to satisfy its valency, we are removing proton from the delta position or not? The delta hydrogen is transferred to the O radical. Thereby we are creating radical here at delta position. It means that what? Here we are generating a radical during the mechanism. See this one. Here we remove the proton, then we are coming up with CH2 radical. Here what will happen? This pi bond is involving in the homolytic cleavage. Thereby what happens? We will create two radicals or not? The CH2 radical and this radical to form a 3-membered cyclic ring, cyclopropane ring, and also we are having another radical. During the mechanism we are removing NO, the NO is going to attach it to this particular radical. So we will come up with what? N double bond O. If you want to write the oxime, what should we do? From here we need to do the isomerism. Thereby we will come up with the oxime as the main product. So this is the what? First application of this Barton reaction. The Barton reaction is not only observed in the steroids, that can also be observed in bicyclic compounds. Let us see the second example. See this molecule. It is a bicyclic compound or not? In the bicyclic compound, we are having OH with respect to this OH alpha position, beta position, gamma position, and this one is delta position. This one is also delta position. Already we know that the stereochemistry. See the stereochemistry of OH group. The OH group is below the plane or not? That's why it can influences this particular CH3, but not this CH3. Why? Because this CH3 above the plane, this one is below the plane. That's why the nitroso group is going to be attached at this CH3. Thereby we will get the oxime at this CH3 only. See. This is all about your Barton reaction.